Okay, so that's the point that it means that there's no need for you to cry once again, to have fear of basic engineering and scientific mathematics modules. If you come to online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai, really we are going to help you more than you expected. But remember that you should not ignore to attend your formal educations or your formal classes of basic engineering and scientific mathematics. You have to go, you have to listen, because I don't know everything about basic engineering and scientific mathematics. I just know small portions of it and have an assignment to teach others what I know. I'm learning always the different concepts informally of basic engineering and scientific mathematics. So don't ignore to attend your ordinary classes. But sometimes it happens that you find that you got everything that you need and you got maybe more than what you need. So it depends, it's upon you. But myself, I don't entertain you to miss your normal classes. Just attend your normal classes and also take all of these classes and then enjoy and then get prepared to be the best technicians for the rest of your life. So we are in departments of basic engineering and scientific mathematics. We have, and in this currently we are teaching you 6 courses or 6 modules, and these modules are just for the ordinary diploma, called the NATE curriculum. And today we are learning the course of modules called the Fundamental Rule of Counting, Matrices and Differentiation. So we are in chapter 1, that's called Fundamental Rule of Counting. Fundamental Rule of Counting. So Fundamental Rule of Counting. And then we are in the subtopic, which is called the combination. And in this lecture 7, I want to solve problems of combination. And this module in many institutions in Tanzania is being covered or is being learned in the first semester of the second year of ordinary diploma. How about your institutions? Because I know mathematics is universal. So regardless that I mentioned and I say that I'm going to focus on the curriculums of NATE, National Council for Technical Education in Tanzania, which is actually focusing on the competence-based. It doesn't mean that we have our own mathematics. No, it's just that's the guidance, the boundaries that I'll be taking in order to make sure that I don't overdose you and also I don't underdose you. Okay, that's my main objective. So let us go to the quick review. If you see lecture 7, it means there are already 7 sessions which have already been recorded and uploaded. So quick review of what? Of lecture 6. Quick review of lecture 6. So the quick review of lecture 6, we say that, wow. So in lecture 6, first of all, we introduce to you what the meanings of combination. We say that combination is a selection of what? Is a selection of items in which the order of what? Of arrangement of those items or objects, order of arrangement is not taken into consideration. It's not taken into consideration. That's how we define it. It's not taken into consideration. While in combination, we take them into consideration. So this is the first point that I want you to know. The second point, we say that if you have n combination k, the general formula for the combination, n combination k, this is equal to n factorial of what? N minus k factorial and k factorial. Remember that I told you don't crave for the letters. It can be n combination r. So if it is n combination r, we have n factorial of what? Over n minus r factorial, then r factorial. So this is the formula. But also I showed you the relationship between combination and factorial. Then to start, let me just begin with correction of the homework. Let me begin with correction of the homework, because I know that the way I wrote that question is possible that it was cumbersome for you to go through. So we are in correction of what? Correction of homework 6. Homework 6. And the questions was straightforward. And you have to solve it. So I think that you solved it. Send your solution in the comment section so that you may enjoy the beauty of engineering mathematics. Okay, so the question stated that solve for n. So it was example 25. So it was example 25. So it was example 25. And the questions was stated that solve for n. So we'll be solving only problem in this lecture. Given what? So be given A, 4, N, 2. We'll be having 3 lectures in this concept of combination because it's very important and it used to appear in many exams, in many diploma exams. So solve for n. So you have to find the value of n. So solution. The first step, we say that the given equation is a equation of combination. So this is an equation of combination. It's an equation of combination. So what does it mean? So you have to note this. Not from today. If you have n combination r, this in other words in mathematics, we just write that n, then you don't write any letter or c there, and then r. Whenever you see these notations in mathematics, whether that basic engineering mathematics or basic scientific mathematics or maybe higher undergraduate in engineering mathematics or higher undergraduate in scientific mathematics. So once you see this, you have to understand that this is n combination r. So we read this as n combination r. That's the concept that you have to remember. So we say that for if that's the case now, we go for the second step. Okay. So second step, suppose that this is question 1. So consider, let's say that consider left hand side of what? Of equation 1. So to consider the left hand side of equation 1. Left hand side of equation 1, this you have 4, then we have n, then you have 2. This is equal to 4. 4, this is n combination 2. Pardon the meaning. So 4 times n combination 2. So from the general formula of combination, so n combination r, this is equal to n factorial. Then here we have n combination 2, n combination 2, this is equal to n factorial. Then we have n minus 2 factorial, 10 times 2 factorial. Right? So if now we have 4, n combination 2, this is equal to 4, then we have what? N factorial of what? N minus 2 factorial, then 2 factorial. Okay? So with this case, you say that this makes 4 n combination r. N combination r. So here we have n minus 2 factorial, then times 2. So 4 n combination 2. This is equal to what? This is equal to 4 times n minus 1, then n minus 2. So we have to expand the factorial function in numerator. So you can simplify this factorial function in denominator. So here we have n minus 2 factorial. So this factorial function cancel. So on left hand side, so now we enjoy the beauty of basic engineering scientific mathematics. Do you love to solve mathematics problems? You have to love it. So then now the left hand side, which is 4 n combination 2, this is equal to what? Is equal to 4 expand. It will be 4 times n square minus what? 4n. And then we say that in numerator we have 2. So we simplify 2 is 4. and with 4 here. So it means that 4 times n combination 2 in a simplified form, this will make 2n square minus 2n. So this is equation 2. This was equation 1. Okay, so that's the second step. Are you enjoying the beauty of combinations? Are you enjoying the beauty of basic engineering, scientific mathematics? You have to enjoy it. So we go for the third step. The third step, we say that consider right hand side of what? Of equation 1. So the right hand side of equation 1 is n plus 2, then combination of 3. So I told you that the definitions of this, it is n plus 2, then combinations of what? Of 3. So we have to use the definition. So definition, this also is equal to what? N plus 2 factorial, and hence the denominator will be n plus 2 minus 3, and hence times factorial times 3 factorial. Okay? So let us find the expression or the equation for the right hand side of equation 1. So now you enjoy the beauty of basic engineering and scientific mathematics. Make sure that you share these contents with other basic technicians in the country and other basic technicians worldwide. And even in some of the undergraduate institutions, they are learning this stuff. So you can share with them. So we say that n plus 2 combination of 3, this is equal to what? This is equal to n plus 2 factorial. Then simplify the denominator. The denominator here we have n. 2 minus 3 is equal to n is equal to negative 1. So n minus 1 factorial. And then so you have what? 3 factorial. Then we have to think between because you have, this is the factorial value, and this is factorial function. So you have to think between these two factorial functions, which one can we simplify, or which one is a subset of the other. So this factorial function is the subset of this factorial function. How? So we can expand this one, right? So that, let's say that we can form equation 3. So we say that the first step, we say that expand what? Expand n plus 2 factorial, and then keep n minus 1 factorial. So we say that we have n plus 2, then combinations of this. This is equal to what? N plus 2 times what? Times n plus 2 minus 1 times n plus 2 minus 2, then times n plus 2 minus 3. Yes, minus 3, then factorial, because we have obtained the factorial function in the denominator of this equation. So here we have n minus 1 factorial, and we have 3 factorial. So this one will cancel with this one, because 2 minus 3 is 1. So it will be n minus 1 factorial. So these factorial functions, they are going to cancel. So if that's the case, now we remain with what? N plus 2 times what? N plus 1. Then n plus 2 minus 2 is equal to times n. And then it's divided by what? By 3 factorial. And 3 factorial is 3 times 2 times 1 factorial. So in this expression, we can expand. So if you expand, we have n. So we have n squared plus 3n plus 2 divided by what? By 6. 10 divided by 6. So we say that okay, n squared. Yeah, so n squared 3n 10 plus 2. So then this will make what? This will make n cubic plus 3n squared plus 2n, then over 6. So we form the first equation. I'm not sure if many students have gone through this expression. This is the beauty of online and Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. So we are learning stuff digital by using the digital technology. So n plus 2 combinations of 3, and then this is equal to what? This is equal n cubic plus 3 n squared plus 2 n over what? Over 6. So this is equation 4. So we have equation 2, equation 3. No, we have equation what? We had equation 2 and equation 3. So we go for the fifth step. Fifth step now, we say that let us equate what? Equation 2 and what? And equation 4. So to equate equation 2 and equation 4, on this side we have what? On the left hand side we have 2n squared minus 2n. This is equal to what? Is equal to n cubic plus 3n squared plus 2n over 6. Okay? So multiply by 6 on both sides. This will make 12n squared minus 12n. This is equal to n cubic plus 3n squared plus 2n. Okay? So we have a choice. We can bring this on the left hand side and equate equal to 0. So we are going to have n cubic plus what? 3n squared minus 12n squared plus 2n, then plus 12n. Right? This is equal to what? Is equal to 0. Okay? So here we have n cubic plus what? Not plus, this is minus. Minus what? Minus 9n squared, then plus what? Plus 22, and this is equal to 0. So simply, you find that n is common, so we have n squared minus 9n plus 22. Is it 22? Not 22. 2 plus 12 is 14. Plus 14n. Plus 14. This is equal to 0. So we can simplify like that. So from this expression, n is equal to 0, and also n minus 9n plus 14 is equal to 0. So this will make equation 5. So you go 40 for the sixth step. The sixth step, we say that solve equation 5, which is quadratic equation, whether by using the general formula or by using the scientific calculator. So the first value is n is equal to 0, which is invalid. Remember that we can prove it is invalid. So you can take your scientific calculator. It just also to remind you that in Online Diploma Polytechnic Institute of Tanzania, we do also have what? We also have an online library, and we are selling our original scientific calculator online in any regions of Tanzania, and also with affordable price, and we are selling you the original scientific calculator. So just press more, first time, second time, 30, then see question, then choose for the 2 degrees. The coefficient of 8 is 1, coefficient of B is -9, 1, then coefficient of B is -9, coefficient of C is 14. So we find that the second value of n, n2, is equal to 7. And also n3 is equal to 2. Okay, is equal to 2. So you see that you have 3 values. N is equal to 0, n is equal to 7, n is equal to 2. So what the exactly value? So to know the exactly value, we have to remember that we had what? For instance, that we had n plus 2 on the left hand side. So this is the timeline for proof to know whether these two values are, or these values are they satisfying the equation or not. This question, remember, I took it from the tutorial. So it's 4n. So now we say that this is, you can do roughly. So identify the value of n. Value of n. So identify the value of n. We have 4 n combination 2. Is this equal to what? Is this equal to n plus 2 combination 3? That's the question. So we have to, what if n is 0? N is 0, it doesn't satisfy. So first of all, n is not equal to 0 for this case, because you cannot have 0 combination 4. Then what if n is 7? So when n is equal to 7, we have 4, then 7 combinations of 2. On this side, we're going to have 7, we are going to have 9 combinations of 3. So we can test, is 4 times 7 combination 2 equal to 9 combination 3. So just use your scientific calculator. In session 6, I taught you how you can use your scientific calculator on doing the computations of combination. So it is 7 shifty combination of what? Of 2. The answer is 21. So is 2 times 21 equal to 9 combination of what? Of 3. So 9 combination of 3, it is 84. So this is 1 times 4 is 4. 2 times 4, it is 84. So is 84 equal to 84? Yeah. So it means that one value n is equal to 7. So let us prove for the another positive value, which is n is equal to 2. So when n is equal to 2, we want to prove. So here we have 4, we have n, which is 2. So this makes 4. It is what? 2 combination 2. So 2 combination 2, you know what happens? It is 1. I guess. So it is 2 factorial, 2 minus 2 factorial, 2 factorial. So 2 minus 2 factorial is 0 factorial, which is 1. And then 2 factorial and 2 factorial cancel. So from this case, we say that we are going to remain with what? With 4 times 1. The answer is equal to 4 for the left hand side. The right hand side, we have n. N is 2, so it will be 4 combination 3. So 4 combination 3, by scientific calculator, you can find 4 combination 3. 4 combination 3, so it is 4 shifty combination 3. The answer also is equal to 4. So it means that when n is equal to 4, so the other value, n can be also 2. Because 2 plus 2, it is 4. 4 combination 3 is equal to what? Because we have what? 4 factorial over 4 minus 3, which is 1 factorial. And then times 3 factorial, which is equal to 4. So therefore, the values of n are 7 and 2. So that's the response for that question. So I believe that once you meet with any questions like that, you will click it, or you will click it. Okay. So ladies and gentlemen, let me solve or let me present to you example 26. And this you have to refer the end of semester exam, which are DIT equal to FAE, DIT 2017, question 1. This is question 1F. Okay, so listen and read this question carefully. So it is F Roman 1. Starts to Roman. Find the value of n. Find the value of n so you can get proof that this question appear in exam. Given that n permutation 5 is equal to 10 times n minus 1 permutation 4. And if you do Roman 1 and 2, no, that is all about Roman 1. And F Roman 2 is this one. Proof that n combination n is equal to 1. And this will make 4 marks out. I want to help you to solve that problem so that you may be encouraged to solve all of these types of problems in case of a testing or in an exam. Solution. The question asks, find the value of n given that. So n permutation that. First step, we say that call the formula of permutation. And the formula that we say n permutation R is equal to n factorial n minus R factorial then R factorial. No, there's no R factorial. N permutation R is equal to n factorial over n minus R factorial. So it means that if you consider, so suppose that this is equation 1, we do have n permutation 3. This is equal to n factorial, n minus 3 factorial, and this is equal to 10 P 10 times n minus 1 permutation of 4. So simply, no. I said I have to consider left hand side. No, I didn't say. So this is n factorial. We can expand it to get a denominator. Times n minus 1, times n minus 2, times n minus 3. This is n minus 3 factorial. So here we have 10. You have 10. So you have n minus 1 factorial of what? N minus 1 minus 4 factorial. Okay, so on left hand side we remain with n times n minus 1 times n minus 2. This is equal to what? It's equal to 10 n factorial and hence over what? Over n minus 5 factorial. So on left hand side we have n times n minus 1 times n minus 1. On right hand side we have 10 n minus 1 factorial, n minus 5 factorial. That's what remains. Question 2. So if you expand there, on left hand side you have n, then you have n squared minus what? 3 n plus 2. This is equal to what? N minus 1, n minus 2, n minus 3. N minus 4, n minus 5. So here in the denominator you have n minus 5. See the necessity of the factorial function. This one and this one cancel. Okay, so here we have 10 times n minus 1, n minus 2, then n minus 3. So before this expression was n minus 1, n minus 2. Isn't it? Yeah. Hello, class. So this is n cubic plus 3n squared plus 2n. is equal to 10 n minus 10. So it is n squared minus 5n plus 6. This is n cubic plus 3n squared plus 2n is equal to 10n cubic minus 50n so this will make 60n. Then you have what? Minus 10n squared plus 5n minus 50. So we can bring all of these items on this side. 10n cubic minus n cubic is 9n cubic. Then we have 3n squared this is square. Okay, so that's make 9 cubic. If you bring this on this side, it will be negative 50. 3n squared. Then we say that n times n squared is 10 cubic, excuse me. 10n times negative 5n, it is negative 50n squared. Then 10n times 6, it is positive 60n. Negative 10 times n squared is positive 10 n squared. Now negative 10 times n squared, it is negative. Excuse me, okay? Have to be careful there. So negative 10 times n squared is negative 10 n squared. So we say that again there we have negative 50 n squared. Negative 10 times 6, it is 60. 10n times n squared is 10n cubic. 10n times negative 5n is negative 50, it is negative 50n squared. 10n times 60 is 60n. Negative 10 times n squared is negative n squared. Negative 10 times negative 5n is positive 50n. Positive 50n. Okay, so 10n cubic minus n cubic, this will make it 9n cubic. Then negative 50n squared minus 3n squared will make n negative 53n squared. Then 60n minus 2n, this will make 58n. Wait a moment. 60n plus, so this is 100. Excuse me. No. So we have 2n, we have 60n to be 58n, then this 10, or this 50n, then it will be 100 because this one is 112, no 110, so it will be 180n. So this will be plus 108n. So it means that is 9n cubic n square, negative 53n, then 58, 108n. So then we have what, minus 60. This is equal to 0. So then we go which step? I don't remember even which step that we go. But the next step now, I don't know the number of equation, and even I don't know at which step we are. So solve what? Solve equation above by using a scientific calculator, and you'll find what? You'll find two values. You'll find three values of n. So take your scientific calculator, then press mod 3 times, then choose equation, then press the right side of the play button, then choose degree of 3. The A coefficient is 9. The next coefficient is 53. The next is negative 53. So say A it is 9. Next coefficient is negative 53. Then C it is 108. Then D it is negative 60. So we have the first value of n, which is less than 1, so we don't prefer this. Then the other value of n, it is common. It is 2.5. 2.506. So in factorial function, we do prefer whole numbers. So we can estimate this as 3. So n is equal to 3. That's Roman 1. N is equal to 3. And there we have permutation. But you have to cross-check, possibly that I made a mistake in divisions or whatever and so forth. Just cross-check. So I don't accept this response. Just cross-check. Go through. Okay, so then the part B of this question now proves that we have to prove the second part, that n combination n is equal to 1. That's the simplest proof, right? So n combination 1 is equal to 1. So if you use the definitions of combination, this is n factorial, then we have n minus n factorial, then we have n factorial. Is this equal to 1? That's the question. So then next we say that in numerator we have n factorial, or simply that here we can simplify n factorial. In numerator the dimensions is 1, n minus 1 is 0 factorial. So but 0 factorial is equal to 1. So simply n combination 1, n combination n is equal to 1 over 1 is equal to 1. Hence what? Hence shown. Because the question was asking me to show. So you are done with the calculation. See? Life is very interesting for basic engineering and scientific mathematics. That was all about example 26. Just to cross-check this because possibly I made a mistake. Just to go through that. But it's simple. The issue is I want you to get the concept, the general concept that we are using. So then now, let me just teach you two other examples. Okay, so let me teach you some other examples, prove each of the following, and you see that this question has been taken from this tutorial sheet. So refer tutorial sheet, it was question 23, the DI tutorial sheet, question 23, Roman R. So you see these questions that appear in the tutorial sheet, okay? And then we have again another problem. So we have another problem that we have to solve. And then we end our session. So get prepared. So the next one is, that will be example 26. Example 26. Example 26. How many examples do you have in your mind? So this example 26 we get us from the tutorial sheet. Example 27, excuse me. Example 27, we say that refer tutorial sheet, refer DIT tutorial sheet, and I want to solve question 24. Very interesting question and score. The question asked me to teach you how can you show that n combination R is equal to n combination n minus R. So that is the question. This is the question, very interesting question. We have to think now. It's a little bit now I want to teach you how you can prove. Because finding the value of n, I believe that I did so many examples, and I believe that you can do more examples. Make sure that, because now this is example 27, make sure that also you find your new 27 examples for you to master this concept. So we have to show that n combination R is equal to n combination n minus R. Solution. So this is all about proof, okay? So we say, first of all, the first step, we can number our equation, which is n combination R, which is n combination n minus R, okay? So suppose, let us number this as equation 1. So the second step, so so that consider the given equation. The second step is this. Consider left hand side of equation 1. So if you consider left hand side of equation 1, you have n combination r. So n combination r, this is equal to what? From definitions of combination, is n factorial, then n minus r factorial times r factorial. Can you simplify it further? No, we can't simplify it. But here we establish a new mathematical equation, which is equation 2, right? Next, we go for the third step. The third step, we say that consider right hand side of equation 1. The right hand side we have what? N combination n minus r. This is equal to what? So from the definition, this is n factorial, and then we say that this is n minus n minus r, but factorial, and then this is what? N minus r factorial. N minus r factorial. So with this n combination n minus r, this will make what? N factorial. N factorial. So n minus n. Here we have n minus n plus r, then factorial. And here we are going to have n minus r factorial. So n combination n minus r, this is equal to what? This is equal to n factorial over what? Over n minus n, it is 0, over r factorial. Then here we have n minus r factorial. So this is equation 3. So the question was asking us to show that n combination r is equal to n combination n minus r. So then we go to the fourth step. The fourth step now, we say that the fourth step, we say that we have to equate equation what? Equation 3, equation 2, we equate it with equation 3. That is step. What the right hand side of equation 2 is n factorial. After simplification, we didn't even simplify, we just use the general formula. And then the equation 3 after simplification, we ended with n factorial in numerator of what? Over r factorial, and then here we have n minus r factorial. So by using associative, remember that also we call it associative. Is it associative or commutative? Something like laws of algebra. So this is equal. So simply we say that n factorial of what? N minus r factorial. Possibly, I know many students will be happy and will be very glad if they write in this way, n minus r factorial, because they are afraid to have penalties because of laws of algebra. So hence show that n combination r is equal to n combination n minus r. Okay. That's all about example 27. Ladies and gentlemen, I want now to teach you a conceptual question. I want to teach you a conceptual question. In this conceptual question, is actually challenging. It is, yeah, so it's one of the challenging. It's very interesting. You have to be careful when you want to solve it. So with additions of that, we have this one, n combination r, n r. Okay, we don't have this. So let me solve this one and then I'll leave the other ones at the home. Okay. So let me present to you example 28. Wow. Example 28. And this example 28, write concept. Question has two words. Show that what n plus 1 combination r plus 1. This is equal to what? N combination r plus n combination r plus 1. So you have to show that. Very interesting question. I like it so much. I made it for the first time when I was in my advanced education in one of the high school in United Republic of Tanzania. So after that example 28, I'm going to solve this and then I will give you the homework. That will be the end of this lecture 7. And I invite you to join me lecture 8 now when we'll be solving different questions of combinations and especially word problems of combination and even some questions of the past papers. So stay tuned. So the first step, so we say solution. The first step, let us number the given equation. So consider given what? Equation. The given equation, we have n plus 1 combination of what? Of r plus 1. This is equal to what? N combination r. Okay, n combination r, then plus what? N combination r plus 1. So suppose that this is equation 1. So you go for the second step. Second step, we say that consider left hand side of 40 of equation 1. So to consider left hand side of equation 1 is n plus 1 combination of r plus 1. This is equal to what? This is equal to n plus 1 factorial by using the definition over n plus 1 then minus r plus 1 factorial, and then we have what? We have r plus 1 factorial. Okay? I believe that you're enjoying the beauty of basic engineering and scientific mathematics. So let us solve this example 28 and then I'll leave example 29 as your homework. So after having this one, we just simplify. We say that n plus 1 combination r plus 1, this is equal to. So here we have n plus 1 factorial. And then in denominator, we have what? N plus 1 minus r. So here we have n plus 1 minus r minus 1. Exactly, okay? Okay? And then we have open bracket r plus 1 factorial. So let us keep on simplifying that function. So it is n plus 1 factorial. And then here we have n minus r factorial. And also with r plus 1 factorial. Okay? So is there any relationship? This is a certain factorial function. This is another factorial function. This is another factorial function. So there's no any relationship between those three factorial functions. What does it mean? No any factorial function which is a subset of the other factorial function. The numerator, the factorial function numerator is not a subset of this, of the factorial function of numerator is neither a subset of this factorial function nor of this factorial function. Similarly, this factorial function is not a subset of this function. Also, this factorial function is not a subset of this function. So we cannot simplify further to that extent. We have to stop there as mathematician and then consider the right-hand side of the equation and do the mathematical simplification. And then enjoy the beauty of this stuff. So n plus 1 factorial of what? Over n minus r factorial. Then r plus 1 factorial. Okay? So suppose that this one to be equation 2. Okay, so let me consider the right-hand side. Wow! Mathematics is sweet. Mathematics is sweet. Tell your neighbor. Tell your soul, your heart, your mind. Mathematics is sweet. Mathematics is beautiful. This is queen of engineering. Okay, so we go for the third step. We say that consider the right-hand side of 14 of equation 1. So the right-hand side of equation 1 has two parts. The first part is n combination r. So let me deal with first term, then I'll go to the next term. So if you define this one by using the general formula of combination, this is n factorial over n minus r factorial, then times r factorial. So this is the third equation. The next part, n combination what? R. N combination r plus 1. This is equal to what? N factorial over what? Over n minus r plus 1. And then factorial. Then times r plus 1 factorial. Okay? So we can further simplify. So if we further simplify, this is n factorial. And then on this side, here we have n minus what? N minus r. And then we say that minus 1. Okay? N minus r minus 1 factorial. Then we have r plus 1 factorial. There's a reason for me to write the concept in this question. Okay? Can you simplify further? There's no relationship between these factorial functions. There's no relationship. We say that n combination r plus 1. This is equal to what? N factorial of what? Over n minus r minus 1 factorial, then r plus 1 factorial, and this is equation 4. So this is equation 4. Right? We are solving problems of combination, right? Interesting. So we go for the first step. The first step now, you know, what are we going to do as mathematicians? Substitute equation 2, also equation 3, then the equation 4 in equation 1. Equation 1 above. So you enjoy solving problems of combination. We are solving problems of combination. We are trying to think differently as bestie technicians. So we say that where the equation 2, we have equation 2. Yeah. So the right hand side of equation 2, it is n plus 1 factorial over n minus r factorial. Then we say that what? Times what? Times r plus 1 factorial. So we have to equate the first part, equation 3, is n factorial of what? Over n minus r factorial. And then times what? R factorial. Okay? So plus what? Question 4, we have n factorial. Then denominator, we have n minus r minus 1 factorial. And then we have what? We have r plus 1 factorial. R plus 1 factorial. So we can call this as equation 6. So we have to equate that the left-hand side is equal to right-hand side, right? So we go for the fifth step. The fifth step, we say that consider or simplify. So let us simplify the right-hand side of what? Of equation 6. So the right-hand side of equation 6 is how do we simplify it? Listen carefully. Let me write it here. We have n over n minus r factorial. Then r factorial. This one plus what? N factorial. Then this is what? N minus r minus 1 factorial. Okay? Then this is r plus 1 factorial. So n factorial is common. We don't have a problem about that. There's a relationship between n minus r factorial and n minus r minus 1 factorial. Do you know which relationship is? One factorial function is a subset of the other. This n minus r minus 1 factorial, it's a subset of n minus r factorial. Right? That's one point you have to note. Again, there's a relationship between r factorial and r plus 1 factorial. R factorial, it's a subset of r plus 1 factorial. It means if you expand r plus 1 factorial, we get r factorial. And also if you expand n minus r factorial, we get n minus r minus 1 factorial. So what do we say? You have to note this. You have to be careful in this. Okay? You have to note this. 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 Okay. So the point that you have to note is this one. Listen carefully. Here we have n minus r factorial. Okay? So if you expand this one, we'll find what? N minus r times what? N minus r minus 1 factorial. Okay? So if you expand what? N minus r. Okay? So in positions of n minus r factorial, we can substitute this expression. Is it? Yeah. That's the point. So this will be, so I say that n minus r factorial, if we define, this is equal to n minus r times what? N minus r minus 1 factorial, and this will make equation 7. Make equation 7. Okay. Again, we say that r factorial is a subset of r plus 1 factorial. So if you expand r plus 1 factorial, hence we get r plus 1 times r factorial. So this is equation what? Equation 8. So this is equation 8, and this is equation what? Equation 7. So this is equation 9 now. Equation 9. So we have to substitute. So we go for the sixth step. These mostly are the questions of section B in exam, in the end of semester exam. Substitute equation 8 and then equation 9 into equation 7. Okay? So we know the right hand side, the left hand side, we just know it. So here we are going to have n factorial over, so here we have to substitute with this expression over n minus r times what? N minus r minus 1 factorial. Okay? Then we multiply with what? With r factorial. So then we plus with n factorial. On this side, we have n minus r minus 1 factorial. Then say r plus 1, then r factorial. So at least that now we have similar terms in the denominator. So the numerator terms are similar. This factorial function is similar to this factorial function. This factorial function is similar to this factorial function. We have to take out of the bracket. So it means that n factorial is common, but also we have some factorial function which is n minus r minus 1 factorial, and then we say that this is times r factorial, this is common. So here we remain with what? So 1 over n minus r plus, then in this term remains is 1 over what? Over r plus 1. Okay? Interesting. So then the next state that this is a fraction now. We don't have factorial functions in this part. We just have factorial functions here in numerator and denominator. Remember that our interest, we want to simplify these expressions to equate it with this expression, where we have only factorial functions. So we have to make sure that we eliminate these other rational functions. So we say that the seventh step now. So suppose that this is the 10th equation. So we say that the seventh step, we say that simplify equation 10 above. So to simplify equation 10 above, we have to keep the factorial function outside of the bracket and then find the denominator of the remaining terms. Find the denominator of the remaining terms. What does it mean? So we say that this is equal to n factorial over what? Over n minus r minus 1 factorial, and then r factorial, open bracket. So find the LCM. The LCM between this and this is equal to this term times this term, which is equal to n minus 1, n minus r times what? Times r plus 1. So take this LCM divided by n minus r, we get r plus 1 times 1. So we have r plus 1, and then we have addition. Take this denominator divided by this, we get n minus r. So get n minus r, then we close the bracket. Wow! So we are approaching to the response, the final response. This is n factorial, n minus r, n minus 1 factorial, times r factorial. Then for this part, we have n minus r times r plus 1. Then r plus, so there remains is n plus r. 1 minus 1, it is 0. So plus 0. Alright. So then in the numerator side now, we have what? We have n factorial, or we have n factorial over n minus r, or r minus 1 factorial times r factorial. In this numerator, we have what? N plus r over what? Over n minus r times what? R plus 1. Wow. Again, there's a close relationship between n factorial. We have n plus r. Let me cross check it. We have 1 over. So we have 1 over. So n minus r there in the numerator. should remain with, so n minus r, n minus r. Aha! So here we have, so we take this denominator divided by this, we get r plus 1. We are right here. And then we take the denominator, we divide with r plus 1, we remain with n minus r. So n minus r, r minus r is 0. So this is the one that is going to be 0. 1 plus n. So it remains is 1 plus n. So simply this is 1, n plus 1. Wow, that is good. Again, as mathematicians, we have to think how in this term, which is factorial function, rational factorial function, relating to this term. The good news that there's a close relationship. You know what the relationship? That will be the 8th step. So the 8th step, there's a relationship between this factorial function and this one. You know the relationship. Remember that first of all, there we have n plus 1 times what? N factorial. Simply, this is n plus 1 factorial. That's the meaning. This is the expansions of this factorial function. Right? And then again, we have a relationship between n minus r minus 1 factorial and n minus r. You know what we have there in the denominator? We have n minus r, then we multiply with n minus r minus 1 factorial. So this one, if you define clearly, this is equal to what? This is n, we say that this is n minus r factorial. If you expand n minus r factorial, you get this expression. Wow. So it means that instead of having this and this, we just replace with this expression. Instead of having n factorial times n plus 1, we just replace with this function. Okay? And hence, again, the close relationship between r, so there we have r plus 1 times r factorial in denominator also. This is equivalent if you say that we have r plus 1 factorial. If you expand, we get this expression. So then replace numerator with this expression, denominator with this expression, and this expression. What are we going to get? We are going to get the good news that this one. So remember the left-hand side is n plus 1 factorial over n minus r factorial times r plus 1 factorial. So now our right-hand side, ladies and gentlemen, the Tanzanian-based technicians of the present and future generation, now we have a good news on the spot. Okay? So on the right-hand side, we have n plus 1 factorial. You have to think there. Use your intelligence. Okay? And hence, we have n minus r factorial. Against there, we have what? R plus 1 factorial. So, is the left-hand side equal to the right-hand side? Yes. These are the equal expressions. Wow. We are done now. So we say that we conclude as mathematicians happily that hence shown that the provided combinational function is zero. Wow, it's a good time. I know many students that they are very happy if they hear from the teacher or from the lecturer that it's the end of the session. So the good news that now it's the end of lecture 7. I thank God who have been with me in the preparations, and I thank God who have given the opportunity to join me. I know it has been actual that one of the challenging sessions because I told you that I'm using different teaching techniques and methodologies of teaching students. That's why I usually start with simple examples, then I solve intermediate problems, and then I come to a little bit challenging. This is a kind of advanced problem for ordinary diploma. For undergraduate and advanced students, this is still a simple problem, right? But for your level and for your way of thinking and for your standard that you have to cover, this is a little bit advanced question. So this is the end. I invite you in the next lecture, which will be lecture 8. I'll be solving also problems about combinations, and it will be hopeful, I believe that it will be the end of chapter 1, which is fundamental rule of counting, and it will be the end of combinations. Really, it doesn't mean that that's all that we know as mathematicians. It's just we have to end according to your curriculum, because we should not overdose you, and we should not also underdose you. I remind you, please, Remember that in case you feel from your heart that you want to offer God the free willing thanksgiving, send it through this telephone number in order to support the running cost for this program, because there is a high running cost, and you have a vision to make more than 500 videos and post them in our online Diploma Polytechnic Institute of Tanzania in square bracket in Olenjolai. Remember to subscribe, because you hear that. Right now, we didn't even reach 100 videos. So we're still in progress. Every day we are adding at least a video. So make sure that you subscribe so you get notifications once that we upload any new video about basic engineering and scientific mathematics for the competent basic technicians. Again, share these contents with your colleagues. Read the descriptions. Again, thank you very much. I thank God. I forgot something which is very important for my life of teaching. Homework for me, it's mandatory. So this will be example 29. I gave you a promise in the midst of the session, but unfortunately I wanted to forget. This is wonderful. So I have a breakfast question. I have a breakfast questions that you have to refer. I took these questions from tutorial sheet. Okay, tutorial sheet, because for other diploma we just do lecturing and even solving problems also. Question 23. Question 23C. Question 23C. So the question asks you that you prove that good news, n minus r and n minus 1 combination of what? Of r minus 1. Then we close the bracket. Then plus what? N minus what? N minus 1 combinations of r. Prove that this is equal to n combination r. It's simple.